Hello again, higher algebra students, here with our fourth lesson of the second unit, solving basic and complex power equations. Objectives here that you can see for the day are solving rational root equations and to be able to solve these complex power equations without a calculator. A couple things to keep in mind here as we get going, as we're solving for these rational roots, is to keep in mind what undoes certain operations in mathematics. And so, for instance, if you have something multiplied, to undo it, you would divide. If you have something added, to undo it, you would subtract, and vice versa for these. If it's squared, you would square root it. If you're dividing, you're multiplying. And if there's rational roots, reciprocal roots are what we're interested in. And reciprocal we'll get into here shortly. So let's just look at a couple examples here to kind of recap and to look at some new ideas as well. So right here, with the same base, we just have a product rule or multiplication rule. So the idea here would be that simply that x plus 5 equals 20. Subtract the 5 from both sides, so x equals 15. So this exponent here would be a 15 in order for them 7 to the 15th times 7 to the 5th to equal 7 to the 20th. The second one here takes a little more work because we want to try and get to the same base. It's becomes unusual when we have the 4 as a base on the left side and the 8 as a base on the right side. So let's convert these to be the same base. And if you think about what base might work here, 2 squared to the 5x plus 1 would equal 2 to the third. Now, this takes another turn with the fact that this is squared and this is cubed. So we've got a little more work to do here. And so what we want to look at is the power of a power rule and look at this entire exponent on the left side and the exponent on the right side. So what we really have here is that 2 and then 5x plus 1 equals 3. So I'm going to move over to the right side up here and I'm going to distribute. So I've got 10x plus 2 equals 3. I'm going to subtract the 2 from both sides. So I have 10x equals 1. Divide by 10. So x equals 1/10 here. Now again, this started with getting them to the same base again on each side, and then just trying to determine what can we set equal to each other here. And again, the exponents would have to be equal. And so it's the entire exponent. So then it was understanding that this was power to a power in that situation and solving from there. And again, you could put 1/10 into this equation. So 5 times 1/10 would be 1/2, or 5/10. Plus 1 would be 1.5. So does 4 to the 1.5 equal 8? Yes, it does. That is in fact the case. So, excuse me, not 1/2, 1.5. So we could write it as 1.5 there if we want to. So does 4 to the 1.5 right here equal 8? Sorry about that. 4 to the 1/2 would be the square root. So now, looking down at 1, 2, and 3 on the bottom here, where we have these fractional exponents, what you really want to do is think about the denominator first, because you could take the square or cube root of the value first, and then that makes it easier to then square or whatever it may be without a calculator. So for instance, 16 to the 3 halves would be 16 to the 1/2 and then to the third. And again, we know that because this is power of a power, and 1/2 times 3, or 1/2 times 3 over 1, would be 3 halves. And so I'm just pulling out the denominator and then taking the numerator and making it that second power as I did to the 3 right there. So 16 to the 1/2 is like the square root of 16, so that's 4. So this is just 4 to the third, which of course is 4 times 4 times 4, which equals 64. Okay. Now on number 2 here, we've got this negative fraction in the exponent. So I'm going to just change this right away to 64 to the 1/3. And so now really what I'm doing is just, and again, in the denominator, sorry, because the negative exponent, that means it's going to be in the denominator. And now I just have to think about what is the cube root of 64. So what times itself 3 times would equal 64? Well, 4 times 4 is 16, times 4 again is 64. So this is really 1/4 in this situation. And again, you could do that. You could type in 64 to the negative 1/3 on a calculator and verify that that equals 1/4. But again, trying to do this calculatorless as we can. But for checking answers, once you've shown the steps to get to it, then it's not quite as concerning. But 4 times 4 times 4 is 64. So 64 to the 1/3, which is the cube root of 64, is 4. Now, number 3, this one's a little harder yet because now we have a fraction to a negative fraction. So again, because it's a negative fraction here, in the exponent, I'm going to write 4/9 as a denominator. So this really looks like that. Now, like I said over on number 1, I like to pull out the denominator of that exponent first. So I'm going to take 1 over 4/9 to the 1/2, and then make that go to the third as another exponent. And so now, in that denominator of 4/9, I'm going to take the square root of each of the two values, so each of the 4 and the 9. So this becomes 1 over 2/3 cubed. And again, all I did was took the square root of 4 and then the square root of 9, which is 1/2 is the same as saying square root here, or always. And so now my final answer is going to be 1 over, and then what's 2 cubed? 2 times 2 times 2 is 8, and 3 times 3 times 3 is 27. Well, whenever you get a fraction in the denominator, and especially if it's just a 1 in the numerator, it's very easy to then remedy that by you can pull the fraction out, and when you pull it out, you have to flip it. So the actual answer here becomes 27/8. And again, that's it's a more of a fraction rule there, but that we could dig into more. But when it's anything in the denominator, all you need to do is flip it, and you can pull it right out from the denominator and put it as its own fraction. And like I said, it's easiest when you have a 1 in the numerator because you don't really have to worry about anything else with respect to that flipping of the fraction. So the idea here when we are solving complex power equations is we want to isolate the rational root. So, so the notion of getting that fractional root to be on its own, we want to write that problem using the rational roots. And so if we can write it again with, as a fraction, where if it's a negative exponent, we put in the denominator. It's if we can even begin to split it, if it's 3/2, if we can write it as 1/2 and cubed, that makes your life a little easier. Solving for x, then you're going to use that reciprocal. And what this just means is if we have x to the 2/3 equals 10, then using the reciprocal would mean we're going to raise this to the 3/2, and then what's done to one side must be done onto the other, and then we can simplify and solve. Now this would be a complicated one because the square root of 10 is irrational, but that would be our process there. Just a reminder on reciprocals. So reciprocals are really just going to flip that fraction. So the reciprocal of 2/7 is 7/2, or 7/2. The reciprocal of -5/2 is -2/5. And we keep that a negative because we want it to be a negative times a negative because we ultimately want that exponent to be 1. Okay, so if you look at 2/7 times 7/2, that's 14/14, which of course is 1. If you look at -5/2 times -2/5, that would be a negative times a negative up top, and 2 times 5 on the bottom is 10/10. If it's a whole number, that's the same as being over 1. So the reciprocal there would be 1/4. 1/3 here, the reciprocal there would be 3/1. -6 is -6/1, so the reciprocal would be 1/6. And again, that negative 1/6, you can put the negative on the top, on the bottom, in front. It doesn't really matter as long as it has a single negative there. Keep in mind inverse. So keep in mind this idea of reciprocal and inverse. What we are finding here in the reciprocal is the multiplicative inverse, which means what do you have to get, what do you have to put with it so that the product equals, oh, I'll just rewrite that a little nicer, so that the product equals 1. There's also an additive inverse, which means if you add the two together, it equals 0. That's not what we're talking about here. So this a reciprocal is an inverse, but it's a multiplicative inverse here. So be mindful of that. So putting it together here now, when we want to write the problem using a rational root, what that means is instead of writing x cubed to the 4th root, as you're looking at right there, this would really be x to the 3/4. Okay. And again, the 3 is the numerator because that's the cubing. The 4th is the denominator because that's the rooting here in the 4th root in this case. So that equals 27. Okay, so we've done that. We do want to isolate the term with the exponent, which we've already done here because the problem was just x to the 3/4. It wasn't plus 5 or x to the 3/4 times 10 or anything like that. Now we're going to use the reciprocal. So to use the reciprocal, what we are going to do is we're going to take this left term here. I'm going to put a little bracket around it, and I'm going to put a 4/3 on the outside. And what's done onto the left side must be done onto the right side. So on the left side here, 3/4 and 4/3, 3/4 times 4/3 is just 1 because it's 12 over 12. So that's just x. That's what we want to have here is just x alone. And now we have to think about what is 27 to the 4/3. Well, I'm going to write this as 27 to the 1/3 raised to the 4th. 27 to the 1/3 is 3, so this is 3 raised to the 4th. 3 times 3 is 9, times 3 is 27, times 3 is 81. So our answer here is x equals 81. You can put that into the equation, the original equation, and see that that works out. But again, I rather than trying to find an exponent of 4/3, I split that so that I could cube root the 27 first and then raise it to the 4th power through power of a power rule. Now number 2, again, this one, what we're going to do first actually is just isolate the term with the exponent. You could, I guess, to keep my order here that I had, I will write it using rational roots first, and so and then we didn't need to simplify. That was already taken care of in there. So looking at the second one here, in order to write the problem using rational roots, I'm going to put a -2 out front, and then this would be x to the 4th, excuse me, x to the 4/2 there, because we are raising it to the 4th, but then we're also taking the square root. Okay, so it becomes x squared, but that's what we see there is x to the 4/2 with this 4, and then with the root there being the half. And we're going to raise that to the -8. I'm going to divide both sides by -2, which is now isolating the term of the exponent. So this first step was the first check. Now I'm going to isolate that term. So I have x to the 4/2, or x to the 2/1. I'll just leave it 4/2 for right now, equals 4. Okay. And now I'm going to do step 3, which is the reciprocal, and I'm going to raise both sides to the 2/4. Okay. Now you can see this is where reducing would be helpful, because 4 to the 2/4, the 4th root of 4 is not an easy task. So I am going to, without a calculator at least, I'm going to change this to 2/1 and this to 1/2. So this is 1/2. So all I've done is reduce that exponent fraction. So this becomes just x equals 4 to the 1/2, which is just the square root of 4, which is 2. Okay, so x equals 2 here. I could put 2 back into the equation, get 2 to the 4th, take the square root of that, and then multiply that by -2, and to get -8. So 2 to the 4th is 16. Square root of 16 is 4. 4 times -2 is a -8. So x equals 2 in this case. Okay. Number 7, same sort of thing again. I'll just do this really quickly. I'm going to subtract the 6 from both sides here. So I'm actually going to isolate the terms and write the rational root in one step. So this becomes 2x raised to the 1/3 in this case. Here's a 1/3 because we just have the cube root. There's no square or anything here. It's just the cube root, and that equals 4. Okay, so I'm going to cube both sides because I would need to get rid of this 1/3. So I'm going to raise it to the 3/1. What's done unto one side must be done unto the other. And now I have 2x equals 4 to the 3rd. 4 times 4 is 16, times 4 is 64, and I can just divide by 2. So x equals 32 in this case. And again, that started with both isolating and rewriting this as a rational root. And so I could know that I needed to multiply by 3/1 or just the cube on both sides. One down here, I'm going to divide by 6 on both sides. And this is a little tricky here to get, so this is x to the 5/4 equals, and then what's 192 divided by 6? Let's see, to do this without a calculator, 6 goes into 19 3 times. And so that becomes 6 goes into 12 twice. So this is 32. So we've got 32. Now, we've got the rational root. We've isolated the term with the exponent. Now we've got to use the reciprocal. So to use the reciprocal here, I'm going to multiply by 4/5 on both sides as an exponent. And now I just have an x left over on the left side because the 5/4 and the 4/5 multiply to 1. So it's an exponent of 1, or x to the 1. And let's see, the 5th root of 32. So that's got to be a pretty small number. So let's think 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So the 5th root, so I'm going to write this as 32 to the 1/5 to the 4th. And that is equal to 2 to the 4th, because 32 to the 1/5 is 2. 2 to the 4th is 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is, so 2 times 2 is 4, times 2 is 8, times 2 is 16. So your answer here is x equals 16. And again, divided by 6 was isolating the term. It was written already as a rational root with 5/4. Use the reciprocal, and then simplified, which is just taking this 32 to the 4/5 and turning it into 16 is the simplifying step. Okay, couple more here. So this one here, the exponent is isolated, the value with the exponent. So we have x minus 3 right now to the 3/2 equals 27. Well, I'm going to use the reciprocal first here. So I have to the 3/2, so I'm going to write this now as to the 2/3. That's the reciprocal, which means what's done unto the left side must be done unto the right side. And so here, that exponent takes care of itself. So now I just have x minus 3. And this is 27. I'm going to write it again, power to a power. So I'm going to go 27 to the 1/3 squared. And again, that's this right here, 1/3 and squared is 2/3, because power to a power says you just take the exponents and multiply them by each other. So what we have here, 27 to the 1/3, oh, sorry about that, 27 to the 1/3 is 3, so this equals 3 squared. Again, we're going to square first, so we've got x minus 3 equals 9. We add 3 to both sides, and we have x equals 12. Okay, so what we've done here is we started with reciprocal, and then I split the root here to be a 1/3 and squared rather than just 2/3. Took that cube root down to a 3. 27 to the 1/3 is 3. Squared that to a 9, and then finally added the 3 over to get x equals 12. Couple last ones here. I am going to add the 41 to both sides here. So I've actually got 2, I'm going to write it up here, x minus 4 to the 5th equals 64. Okay, I'm going to divide by that 2, so I've got x minus 4 to the 5th equals 32. And now I need to get to that reciprocal. Now that I have the exponent is rational, the exponent term is alone on the left side. So now I take that reciprocal, that's 1/5 and 1/5. And that gives me an x minus 4 on the left side because these two take care of each other. Simplify out. 32 to the 1/5. Again, should be a pretty small number. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 32 to the 1/5 is just 2 because 2 to the 5th is 32. Finally, I'll add the 4 to both sides. And again, the reason I'm not adding the 4 until the end is because it was in the actual x term there, in the parentheses. So I basically have to get that alone before I can separate the x and then minus 4 there. So I end up with an answer of x equals 6 in this case. Could put 6 back in there. If I put 6 back into here, 6 minus 4 is 2. 2 to the 5th is 32. 32 times 2 is 64. 64 minus 41 is 23. So yeah, that works. Again, I have a rational root already here, so I'm going to isolate the exponent term on the bottom here. So I have x minus 1 to the 3/4 equals 8, leaving a little space there because I'm going to now take the reciprocal. So the reciprocal here is 4/3. What's done onto one side must be done onto the other. And so now I have just, x minus 1 on the left side. And again, I'm going to rewrite the right side here. Sorry, I keep hitting a different the text button here for some reason. So I'm going to rewrite that as 8 to the 1/3 raised to the 4th. Okay, to make that a little cleaner, 8 to the 1/3 is just 2, because 2 times 2 is 4, times 2 is 8. So 2 cubed is 8, so 8 to the 1/3 is 2, and then it's still to the 4th. So I have x minus 1 equals 2 to the 4th. Well, 2 to the 4th is 16, because that's 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. And finally, I'm going to add 1 to both sides. So I have x equals 17. These last couple here, they are a little nicer. As you can see in this problem, these are both just square roots. So this is actually 2x plus 7 to the 1/2 equals 5x minus 2 to the 1/2. So all I'm going to do here is use reciprocal to square both sides, or to multiply them by 2 over 1. So all then that happens is 2x plus 7 equals 5x. So to solve this from last unit here quickly, we subtract the 2x from both sides, and that gives us just a 7 on the left side, because that's gone. 5x minus 2x here is 3x, and then we add minus 2. We're going to add the 2 to both sides. So I'm going to jump up here. So we've got 9 on the left side and 3x on the right side. And you can divide by 3. So 3 equals x, or x equals 3 is fine. And so our answer there is x equals 3. And again, you could put that back into the equation. 2 times 3 is 6. 6 plus 7 is 13. So that's root 13. 5 times 3 is 15. 15 minus 2 is 13. So that's root 13. Similarly, on the bottom one here, 5x plus 3 to the 1/4, because it's the 4th root, equals 2x minus 10 to the 1/4. And I can just take the 4, or raise both of these to the 4 as an exponent. And when I raise both to the 4, now 5x plus 3 equals 2x minus 10. Subtract the 2x from both sides. That gives me 3x plus 3 equals a negative 10. Subtract the 3. 3x equals negative 13. So x equals negative 13 thirds there. So it's an ugly answer, but again, what we're doing in this case is simply solving for x, but in this case, because we got to just go to the fourth exponent for both, it cleaned up pretty quick. So we will leave it at that. Thank you very much, as always, for listening. And if you have any questions, please ask. Thank you.